All right, let's do it. Hello everyone, welcome back to Munro Live. I'm Scott Hoffman, and today we're gonna spend some time taking a little bit of a deeper dive on something we're excited to have, which is Rivian's new dual motor Enduro drive unit. So this is an internally developed unit. We've got all the pieces spread out on the table. We're gonna take a few laps, bear with us. We'll try not to get anyone dizzy, but we're gonna step through all the different constituent components, talk about what design choices are made, some of the unique features we're seeing, and ultimately kind of summarize what we think of the drive unit, right? So let's start at a high level. And first off, it has an awesome name, Enduro, right? So that was kind of the internal program or project name that Rivian's been referring to this unit as. We know that when they launched the R1T, they had a quad motor setup, right? So it was 4 motors, 2 on each axle, 1 on each wheel. And when they say dual motor, the units that are coming in now as an option mean that the whole vehicle has 2 motors now. So when we say it's a dual motor drive unit, it's actually just a single motor, but they're doing it twice in the vehicle. So this unit is set up to be like a drop-in replacement, right? You can still get the vehicle with a 4 motor setup or with a 2, so they made it backwards compatible, but they made a lot of choices to take cost and to take weight out of this, and we're gonna go through kind of what those elements are. Now, if you've seen any of our previous videos or the first one we did on the R1T original quad motor setup, you know that when we're talking drive units, the kind of the 3 constituent elements that we talk about are, people might say 3 in 1, but you've got an inverter, you've got an e-motor, and you've got a drivetrain. So we're gonna go through those kind of individually. We'll talk about those components, we'll talk about how they function together, what differentiates this, and wrap it all up. All right, so with that, let's start with, so high level specs, difference in output between the quad motor one and this. At a vehicle level, they were at about 835. If you get the dual motor performance variant, you're talking about 665 horsepower now. So there is a reduction in output in terms of torque and horsepower on this vehicle, and we'll get to this later. I don't think it's gonna be something that most people will realize. It's neat because from the outside, you really won't be able to tell that this isn't the old unit, but certainly there's gonna be a lot less cost in it. So let's start with the e-motor. So in an electric drive unit, your e-motor assembly is important. It is what's basically, you're taking the power from your battery, you're converting it to AC, you're running it into the stator, which is the stationary element inside of your drive unit. You're creating a magnetic field in these copper windings here, and that is going to play with the magnetic field that exists in the rotator, which is the rotating assembly that lives inside of that. And basically the interplay between the magnetic fields in these 2 things, it induces rotation, and that's going to be fed through the gear train and out to your wheels and ultimately power the vehicle. So looking at this unit, and we should note again, so it's just important to mention, this is, Rivian's doing this one in-house, and that's a big deal because previously they purchased it from Bosch, which made sense in terms of speed to market, but already we're seeing some improvements. They have more control. Looking at this one and comparing kind of to some past things and other things we've seen, this is a relatively conventional stator assembly. This is what's called a hairpin design. Hairpin or a bobby pin, if you think about it, you know, it's like a U shape, if you will. So this has kind of that same profile where you've got a pointy part on one end, it comes up and it loops back. So they're using these hairpins, they drop them into slots. In each slot within these stator laminates, essentially thin sheets of metal that are stacked together, they're putting 5 copper conductors through, and then they're welding them through on the other side. Pretty conventional, I would say, application here. Makes sense for what they're doing. An improvement over what they were doing in the Bosch one. It's easier to put together, fewer welds, but similar to some of the things we've seen on other units. I know specifically, if you just glanced at this and you looked at what we saw in the Ford Lightning drive units when we tore those down, definitely some similarities here. So like what they're doing with the stator, pretty conventional. As far as the rotor, the rotating assembly is concerned, again, quasi-conventional here. We've got a stack of laminates that have an offset in them. That's done for anti-cogging reasons, to try and make the power delivery smoother and resist the propensity for the magnets to sort of cog around and have a twitchy motion. So you'll see that between these 4 laminate stacks, they're slightly offset. And then within here, there are going to be magnets that are pressed in a V configuration. So these are, when someone says permanent magnet AC motor, which is what this is, the permanent magnets are inside of this rotor. The end caps here are still on, so you can't see them, but basically they're embedded within. So you've got a permanent magnetic field in here, and then you've got a magnetic field that you're inducing by passing current through the stator windings here. And again, the interplay between those is what's going to make things happen. As far as this rotor is concerned, again, it's quasi-conventional here. The one thing that I would point out is that's unique, and we'll get to this, is the cooling strategy on this drive unit. It differs a lot from what they did previously on the quad motor unit. On this rotor, one thing I'll point out, so this is the resolver side. This is called a target ring. It interacts with something that's called a resolver. We'll point that out in a moment here. But what's important is this rotor shaft, for a majority of it, is hollow. And that's not an accident. It does save some weight, but there's something that goes in here, and it's an important part of their cooling strategy. I'm going to grab another component here, if we could just back up for just a moment. This is called a resolver cover, resolver housing. Essentially, this is a component that's going to go on the outside of the gearbox like this. It's going to thread through, and that's going to close out the side of this case where the rotor and the stator live. But when that pushes through, this guy is going to thread into the rotor and be sealed. So you can see it buries in there. We've got spots for 3 sealing rings, O-rings that go in there. So what's unique about this is Rivian has made the choice to go from just glycol cooling to pressurized oil cooling in this drive unit. And what this guy is doing here, and we'll show the other elements of the cooling system, but this is an oil jacket that's going to be sealed. They're going to push oil through this. It's going to come down, and then these little holes that are in this tube that passes inside of the rotor, those are going to be little jets that cause oil to spray out and immerse the inside of this rotor with oil that they're using to take heat from the drive unit. So we have seen other folks cool internally to rotors. It is, as we look at the previous drive unit, this is a superior, in terms of performance, it's a superior, certainly more costly, but a better performing thermal management system within here to go to pressurized oil. So they're spending a little bit more cost in the cooling system components integral to this unit to get more out of the motor. So they're replacing 2 with 1, right? And it's not double the size. So they're able to go slightly bigger on the motor, but push it harder by having a more premium offering in terms of the oil cooling. So they're pushing oil into the rotor. And I'm going to show some of the other elements here that are part of this cooling system. Let me set this down. So when we say pressurized oil cooling, what is important for that, to induce the pressure, you have to have an oil pump. So that's what this element on the outside of the case is. And as we look competitively speaking at other folks that have had systems like this, Tesla has always had pressurized oil cooling. Also, when you have a system like this, a giveaway is you have an external oil filter, which you'd see on any of the Tesla drive units you looked at. But with this, essentially, they're going to be pushing oil through these jackets in the case housing here. And what's also important is you need to have a heat exchanger, which is what this is. So this plate heat exchanger, they're going to pass coolant glycol, so a mixture of coolant and water, through one portion of it, and then they're going to have oil flowing through the other portion of it. So the way this is set up, and you can kind of tell the glycol goes in this portion because they've got a little bit of corrosion there, which is kind of a giveaway when that residue is dried coolant. But they're going to pass coolant through the jacket of the housing here. It's going to go into this plate exchanger here, and they're going to have oil going on the other 2 portions of this. And when they take the heat out of the oil in that fashion, it's going to flow to other areas in the case, specifically into the rotor, which we were talking about. And then I'm going to show you a couple other areas that receive oil as well. So if we turn to the inside of this case, that oil that's coming through, you can see they've got a plastic carrier here that comes to a point and creates 2 nozzles that are spraying the rotor shaft. So again, finding another way to bathe it, they've got 2 jets that come out here. They're going to be hitting it with oil there. And additionally, one of the other oil jackets, which is up here, they're going to be going through, and there's a component, if I can rotate this, they're going to be pushing oil through this housing into 2 dispersal assemblies. Some people call them oil squirters, but essentially it's a 2-piece assembly. This is one side of it. There's going to be a jacket upstream of this. When the oil comes through, it's going to force it through, let's see how many, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of these little nozzles. This tube connects in here across the top of the case. You can see it bolts on like that. It's got a little seal. So there's another one of these sort of crescent assemblies on this side. And what that's going to do, I'm going to grab a component if you want to stay there for just a moment, and we'll bring the stator around. These are heavier than they look. So those units that are spraying down are going to do so roughly in this orientation. So they're going to drizzle oil, or spray it rather, down onto these copper conductor bars, which when you're passing current through them are generating heat. And so if you want to take the heat out of that, basically immersing them in that is a good thing to do. So they're going to be doing that on both sides. And in addition to that, as we saw earlier, they're passing it through the rotor. So this is, again, and also as it's drizzling down, I should note this half of the case, this is going to be filled with oil. So this whole rotor stator assembly is going to be bathed in oil, which is something that was not the case on the previous unit. They were only taking heat out from the case itself by passing coolant through it. So definitely going to be able to get more performance out of this motor by making these choices, and it is in line with, competitively speaking, what we see others do on the more sort of premium side of things. Now, as far as, again, the rest of the cooling system, I'll just note here, I'll put some of this back together. When we talk about the sequence of cooling in an electric motor setup or an electric drive unit setup, we've got the inverter that would be on the top here, and I just want to kind of show the coolant flow. So the power switching components in your inverter are going to be one of the hottest destinations. So you want to cool that first in terms of closest to the source of taking heat out. So this is the coolant inlet. We're going to go in through here. You can see there's a jacket that goes to the side here, and it's going to go, and we'll flip it over and look at it. Worth noting here, so to get these jackets in there, they have to drill them out, and you can see that's why they have, this is a plug. Essentially, they need to gun drill through here to get the jacket that they want, and then they're plugging it afterwards. So just that's necessary to manufacture the coolant paths that they want to here. But coolant's going to go in through here, and then we'll flip this over. On the underside of this assembly, you're going to have cast-in heat sink features that are taking heat out of the power switching components. We'll come back to these in a little bit, but essentially these are one of the hottest things in this. On the back side of this, you want to take heat out of them. These power switching components are what's taking the DC power in your batteries and switching it to AC that's going into the motor, and they heat up pretty good. So those are the first destination. Then that coolant's going to flow by and come out of this jacket. And if I flip this back over, you'll see that you've got a male side that meets this female portion here. I'll set that back up. As that comes together, you'll see that that's going to mate right with that, and it drops in. So that's going to pass the coolant. We came in here, we passed through the heat sinks on the power switching components, we went down. Now we've entered the case, we're going to pass through here, and then if I put this end plate on, so we saw we had coolant coming through here. Now we're going to go into here. We have another gun drilled element, and we're going to go into that banana shape that we talked about earlier, which is where on the heat exchanger, when that mates up, that's where you got the coolant going. So it's going to go through there and then continue. Well, actually, it's going to go down through here and up and then out of this. So essentially, into this drive unit, you've just got inlet and then outlet through the heat exchanger. We've seen other people do that a little bit differently, but this is actually kind of clever. I like that. It's pretty integrated, and they only have, we've seen like on Tesla, for example, they go into the inverter, out of the inverter, then into the drive unit, out of the drive unit. With this, they only had one in and one out, and then the jackets they achieved internally. So pretty clever there. Also looks like they may have like a shutoff valve integral to this, which not exactly sure what or how they're using this, but as you think about, sometimes there's a need to generate heat in an EV in a productive fashion. They could be using this potentially maybe to block off the cooling and maybe torque the motor to generate some heat. We know that's something that Tesla does, essentially putting the heat to good use if you're trying to warm the vehicle up. I suspect it could be tied to that. But yeah, so from a cooling perspective, definitely I think a better system than what existed on the previous unit. Like to see that. And yeah, as we work around here, so kind of we'll take a lap around the table. I want to give folks a chance to see the other side of this drive unit before we circle back. I'll take this back off. So as I noted, this is backwards compatible. So to enable that, essentially they had to build this case in such a way that it was able to have the same mounting features that the previous drive unit did. And so the housing, it switched from being a lot of extrusions to being cast, which is great, fewer pieces, but the mounting points to the vehicle, the interface, is going to be the same. So this mount goes up to here, that's your outboard most mount. This looks essentially identical to what was on the previous unit. You've also got two mounts that look roughly like this that come on the front side. So this is a 4-point mounting strategy. You've got one here, one on the other side. So even though it has a single motor in this unit, from a packaging perspective, they had to do it in such a way that it still lines up with the space that the previous unit took. So this side sort of juts out in that triangular configuration. What they had to do on this side was build a big, essentially standoff to basically make it packaged. So the way this goes together, if I take this case half, bring it up here, and then I take this piece, that goes like that. So it gives them still access to get to some of these things for service, gives them room for the heat exchanger, but it bounces this out probably further than you'd otherwise need to, but it does it in a way that allows it to be backward compatible, which was critical without having to, do a complete tear up of the vehicle and make it so it couldn't be, offered in both configurations. So we'll pull that off of there. All right. So another thing I want to talk about is the gear train on this unit, and what's important here, and this is probably maybe one of the most significant differences between the two vehicles. Before you had 4 motors, and so each wheel was being independently controlled. So you had, from an off-roading perspective, completely independent torque possibilities at each wheel. By going to a 2-motor vehicle setup, you now have 1 motor that's driving 2 wheels, one at the front, one at the back of the vehicle. So to do that, you need to have what's called a differential, and it's something that most EVs and most vehicles in general have out there on the road. A differential is a gear train setup that allows you to have 2 wheels rotating, being driven by the same force, but allows them to rotate at different speeds that accommodate things like going around a curve. Because when you go around a curve, one wheel actually rotates faster and the other one slower than the other. And so if you didn't have a differential, you would sort of crab hop. If you've ever put a vehicle in true 4-wheel drive and tried cornering in a dry parking lot, you know what I'm talking about. But essentially on this one, they had to add a differential, which was something that didn't exist before. But in doing that, they also needed to keep the capability to decouple the drive unit, which is something that they had on the previous vehicle, but they did in a different fashion. So I want to kind of walk through that. When I say differential, this differential gear set with the planets and the suns in here is housed within this ring gear. This goes on to that side. You got a splined interface in here. That's going to be what your half shaft that goes out to the wheels plugs into. So you got one there, and then you've got one on the other side. So when the half shafts are in there and this vehicle is powered, again, it's going to allow these to rotate at different speeds and allow some slip between them. But that decoupling that I mentioned, so this is something that's done for the means of efficiency in reducing the drag that a permanent magnet motor places on a driveline. On the previous vehicle, they had a setup for a disconnect that was on the outside of the case, between the case and the half shafts. This time it's been integrated into the drive unit and they have 1 instead of 2. And the way this works, I'll kind of demonstrate here. So they've got a spring washer that sits inside of this gear setup here. Then you've got an intermediate piece that essentially, this is going to be what locks, engages and disengages between the two. This goes on here. I'm never going to be able to line up these teeth perfectly, so it slides in. Essentially, that sits in place there. That spring washer is going to provide tension that in the resting state is going to keep this pushed further outboard. And when it's in that outboard state, these inner teeth are engaging on this inner gear and basically making it so that the relative motion between this outer ring gear and then this inner portion, when that is pushed to the outermost portion, those are going to rotate as one. And that's important because when you walk back through the gear train, this is going to spin with the motion of the rotor and stator, so your electric motor assembly. If you want to, like say you're driving and you want to be as efficient as possible and you don't want to do regen and you don't want to get that back EMF, back electromotive force, they've created a way for them to decouple this. So with that, they've got an electromagnetic ring in the case here. So this can go in and out by applying current to it. It's in its extended state right now. If I push on it, you'll see it goes in slightly. So essentially they'll pass current and voltage into there. That'll push it either in or out. And when they push it in, this splined assembly that was joined to here, you can see if you look in here, the innermost portion of that doesn't have splines on it, right? It's smooth and machined around there. So basically when that gets actuated and pushes out, it's going to cause this ring to push inboard, which then will allow this, which moves with the wheels, to move independently of this outer ring gear. And that's significant because that removes the mechanical propensity for the electric motor to move when the wheels are moving. So disconnects are something that have been done in both ICE and electric vehicles for years. We saw them a lot on ICE. It's done for efficiency and to get better range, whether that was just for MPG or for MPGE. We're seeing it as more of a trend developing in EVs. Rivian had it on the original vehicle, but it was sort of done with 2 bolt-on units. Love that this is integral. This is consistent with what we're seeing on like Hyundai's eGMP platform. We know Mercedes is using disconnects. People are doing it. They're seeing real reduction in, well, improved efficiency in the range of anywhere from 5 to 10% that allows them to do more with fewer cells in the battery pack. So I like how this one's set up, still using an electromagnetic mechanism to actuate it, but instead of having 2, they have 1. They've got it set up in such a way that it's compact, doesn't take up undue space in the drive units. This will, though, the way this is set up, probably require potentially different drive shaft lengths from one vehicle to the other. I guess we'd have to see them both to confirm that. But it's packaged and stacked up in a different way, but this is definitely a less costly and more efficient way to go about it. So like that. And I guess it is worth mentioning too, from a vehicle control perspective, the way that torque is delivered, having a differential versus having full independent wheel control. There are probably the purists, and especially the people who wheel these most hard in an off-road scenario, maybe they'll be able to tell the difference because you can put more power to a single wheel. But a lot of that, gosh, I think most people won't be able to tell the difference. You can still do independent torque vectoring basically by using, when you have a differential, you can still meter what the wheels are doing by using the brake system. They've got electrically actuated calipers. So it's, a combination of, it's an e-booster pushing a hydraulic system, but essentially they have electronic control over their brakes. You can do a lot of things to simulate different drive modes. I think most people won't even realize whether they have the quad or the dual. A lot of the stats are just kind of going to be noise as far as most people are concerned. So I think it's a good value there. Working around, last thing maybe we haven't touched on in detail, so the inverter, and again, this is kind of in the role that this plays in the vehicle is going to be important in the sense that it's kind of the brains of telling your motor what's going on, what it's doing, and it's taking the power from your battery, that stored DC power, and it's going through, these are kind of the big dollar items in here, your power switching components. Those are going to switch that power from DC in the battery to 3-phase AC that's going to go, well, it's going to go, so these 3 leads that come out of here are going to go down into the stator windings. So you can see, if you look up there, those big kind of copper pieces, those pass through. And you can see on this side, they go to a threaded interface, and that is going to bolt to these 3 guys in the stator. So this is going to be what is passing, sort of the flow of power from your battery goes through the inverter and into your electric motor. So again, this is a big source of heat, kind of your main components in here. Power switching components, you've got a big capacitor, you've got a current sensor, and then you've got the cooling provisions that are taking heat out of this. Looking at this inverter, what I like about this one as compared to the outgoing one is this, essentially all of the guts of the inverter are on the top of this case half, and it doesn't have a separate bottom piece. So this goes on as one unit, it mounts in place, and there's not a separate need to seal at multiple spots. They do have the seal up there, but if you looked at like a Tesla drive unit, very similar in that the inverter goes on to the cast housing, it's sealed. This is definitely a more competitive strategy than what they were doing on the previous one. A little bit of an advantage in the packaging here. It was a bit easier to do with this unit, but the inverter is going in a direction that is definitely more efficient from a cost and weight perspective. And I think in total the drive unit, this one versus the outgoing dual motor setup, or dual motor drive unit as part of the quad motor setup, it was a delta of about 30 kilos, slightly more. So 30 kilos, 60-ish pounds, a little more. You double that in the vehicle because there's 2 sets of them. That's a significant amount of reduction there, right? So less cost, less weight. You do have about 20% less horsepower and about 10% less torque, but those trade-offs, when you look at the difference in MSRP of the vehicle, I think you could get the standard dual motor setup for $8,000 less than the quad, and if you get the dual motor performance, it's $3,000 less. So I would say it's good to see Rivian's passing on some of that savings. Certainly in making these changes in the drive unit, they are realizing significant cost savings as far as their BOM is considered, their bill of materials. So yeah, it's exciting to tear this down. I know this is consistent with the direction we were hoping to see them go. It's bringing the cost down, it's making the vehicle more competitive, and I think from an end user perspective, it's going to do the job just fine. Objectively speaking, the vehicle's performance characteristics are at the high end of the charts, if not off the charts. So I think most people would be pleased with it. And from a value perspective, if it was my money, I would definitely be buying the one with this unit as opposed to the quad. So thank you for joining. Hopefully this has been insightful today, kind of taking a closer look. Again, a huge thank you to Rivian for making one of these Enduro drive units available for us to tear down and have an advanced look at. Thanks for joining. Have a great day.